Hi, welcome back. So in this video, we are going to be discussing about the arithmetic operators that are available in our C language. So C language actually supports 5 arithmetic operators, and those are addition, subtraction, multiplication, division, and modulo operators. Okay, so basically we already know about these operators, right? We have been using them right from our basic maths classes. So addition, we know that it is used to add the two numbers. So subtraction, to find the difference between the two numbers. So multiplication, where we are going to multiply the values, and division and the modulo. So the main thing here, what we have to focus is, the first thing is difference. So difference between our division operator and the modulo operator. So remaining all, we already have a fair idea about, right? So what is a division operator going to do, and what is this modulo operator here? So first thing, whenever I perform a division operation, okay, so the points that I have to remember. So whenever I'm going to perform a division operation, the points I have to remember is, first thing is, when I am going to perform the division, it is always going to give me the quotient value. That is, for example, let us say 10 divided by 3. So this is the operation that I want to perform. So the output of this is going to be 3. So it is the quotient value that is always returned back with my division operator, right? So it is going to give me the quotient value, right? So same thing, when I'm going to do the same type of operation using my modulo operator. So what is that going to do? So same thing, I'm going to say 10 modulo 3. This is also going to perform the division. Okay, the modulo operator is also going to perform the division. But what it is going to return back? It is going to give the remainder of the division operation. So whenever it is going to perform the division, it is going to return back the remainder value. Say for example, the same thing, 10 modulo 3. 10, it is going to give the remainder as 1. Because when I divide 10 by 3, 3 into 3 is 9. So 9 times. So minus 10 minus 9, 1. So 1 is the balance, or 1 is the remainder that I'm going to get. Suppose I'm saying 10 mod 2. So here, what is going to happen? 2 into 5 are 10. So it is a clean division. There is going to be no remainder at all over there. So the remainder is going to be 0. So this is the first difference between the division operator and the modulo operator. So the division operator always returns the quotient value, and the modulo operator always returns the remainder value. Okay, so again, this is a general difference. There is one more very important difference between these two operators, and what is that is, division operator can be applied. Okay, division operator can be applied on any type of numbers. Now, what do I mean by this? Okay, so another very important difference is, division operator can be applied on all numbers, or rather to say all number data types. That is, I have my int, I have my float, I have my double. All these are number-based data types, right? So integer, whole numbers. It is going to store only whole numbers. When I talk about float and double, it is going to store fractional values, but that is also a number. So the division operator can be applied on all numbers, whether it is an integer, and in integer itself, we have the variations, right? We have short int, we have long int. So on any type of integer values, I can apply the division operator. Same way on a floating point value, on a double value, yes, it is possible. But when we talk about the modulo operators, please remember this difference very carefully. It can be applied only on integers. Only on integers. If you try to apply it on a float or a double value, it is going to end up throwing errors. So this is another key difference between the division operator and our modulo operator. So let us just try to see an example for this. Right, so there you go. I am just going to say %t, comma, 10 plus 20. I'm just going to directly print the results. That's it. Let us print the second one in a new line. So let us use the minus operator. So addition, subtraction, and of course I have the multiplication. Okay, there you go. For the division, okay, I am applying the division on an integer value. At the same time, I am applying the division operator on a double value also. Remember, whenever we are not creating any variable, suppose if I am saying like this, when I'm saying like this, float f is equal to, then I'm giving the values like this. Then this is a floating point value. Then this is a float. This 10.23 is of the float data type. Yeah. Okay, but now here, I am not assigning it to any variable. I'm not creating any variable. I'm directly giving the values. So I'm saying 45.5, 3.0. So this is by default treated as a double. I hope you guys remember that. Right. So this I'm applying the division operator on a double value. Right. Then we go. Let us apply our modulo operator. So I'm saying 10 modulo 3. And then let us say 10 modulo 2. Okay. Now let me run this program first. So yeah, there is one small change what I have to do here. Here I'm applying the division operator on a double data type. So the result of that obviously will be in a double, but for that I am using a percentage t. That is why it is throwing me a warning. See here, it is not an error. It is not throwing me an error, but it is throwing me a warning. And see what it says. Percentage d is an argument of the integer data type, but what we are using here, see, by default it is taking this as a double value, and I am trying to assign that to an integer. So that is the mistake here. So it is throwing me a warning and not an error. So let us modify this. So what is the format specifier we use for a double? I'm going to use LF. Now let us run this. See, this time there is no warning also. Right. So yes, 10 plus 20, the result is 30. So 10 minus 20, yes, minus 10. 10 into 20, 200. Perfect. So 25 divided by 5. Look here, both the operators, like both the operands here, that is 25 and 5, both are integer values. That is, both are whole numbers. Hence, the result also will be in an integer value only. Okay, but here in this next scenario, in line number 8, what is happening? Both the operands are of double data type. Hence, the result is also going to be of a double data type. That is why I'm using percentage LF here. And this is the output I'm going to get for this. And see here, 10 mod 3. Yes, the remainder is 1. And 10 mod 2, the remainder is 0. So this is how my basic arithmetic operators is going to be working, and the difference between the division operator and the modulo operator. Right. And I told you one more point. Right. What did I say? Modulo operator cannot be applied on a floating point or a double data type. So let us try that also out. Okay. So I'm saying 10.5 modulo 2.0. Okay. Now let me run this program. See what happens. It is not running at all. It is throwing me a compilation error. So the error is a compilation fail. What is the error? It says, see which line it is pointing me, line number 11. What is there in line number 11? Line number 11 is what is having this modulo operation. See where the error is showing. So invalid operands. So have double and double percentage operator. That is my modulo operator cannot be applied either on a float or on a double data type. So it can be applied only on integers. All type of integers, short int, long int, those things are accepted, but not on a real numbers. Okay, so this is the first thing you should be knowing about your arithmetic operators. Okay, other than this, there are a few more points which you should be aware of whenever you're going to make use of these operators. So what are those points is what we will be discussing now. So the first thing, Okay, let us say, what do you think will be the output of this? Let me say printf. So see here, as I told you, whenever we are going to perform the operations on both my operands are integers, then the result also will be in an integer value only. So never forget this. This is the first point. See, it is giving me only the result as 3. Okay, 17 divided by 5, it is giving me the result as only 3 and not 3.66 and all. So I will get 3.66 when this is going to be either the numerator or the denominator. If it is of a float or a double value, then the result will be in form of a double or a float. But otherwise, it is always, if both operands are of integer data type, result is also of an integer only. So what is going to happen here? Truncates. It just truncates any fractional values. So whatever fractional value you're going to get, it is going to be truncated and only the whole number is going to get printed here because it is of integers. Right, this is point number 1. Okay, point number 2. We are familiar with the plus and the minus operators. Right, so plus operator is going to do addition work, minus operator subtraction or the difference between the numbers. Yes, so now there is the plus operator and the minus operator can also be used as a unary value. Now, what do you mean by this unary? Unary means you are going to apply it on only a single operand. See, normally what will happen when I use a plus operator? So let us say A is equal to 10 and B is equal to 20. Now, when I want to apply the plus operator, what I'll do? A plus B. So I will be making use of two operands here. So A is one operand, that is A is one variable, B is one variable. So I will be applying it like this only. But what I'm saying is there are certain things, the plus and the minus operator. Okay, it can be used as a unary value also, unary on a unary operand also. That is, for example, let us say printf %t, comma, minus 10. Now, what will be the output? We use this minus symbol to represent, this is a subtraction operator, right? But we use it to represent that this is a negative value. Right, so this is what I mean by a unary operation. So the plus and the minus operator can be used in this format also. Right, so minus operator, we use it to represent the negativity. That is, this number is a negative number. So what will happen if I use like this? There is no need for me to use this plus symbol, right? So when I say 10, obviously 10 is a positive number. By default, whatever value we are giving, it is always considered as a positive number only. So there is no need for me to say it is a plus 10. But still, even if you use it also, there is no error. You can use it. So both my plus operator and the minus operator can be used as a unary also. That is to represent whether the number is a positive number or a negative number. So this is the second point, what you have to remember here. Now, point number 3. With regards to the arithmetic operators, point number 3. Let us take an example. I am saying 6 divided by 7. What is going to be the output here? Remember, both are integer numbers. Both are integer numbers. And my 7, that is my denominator, is greater than my numerator value. So obviously, it is going to give me the result as 0. So 6 divided by 7 is going to be 0. See, if it is a floating point number, it will be 0 point something and all. But since it is and both are integers, it is just going to give me the result as 0. But now what is going to happen? When I'm saying minus 6, minus 7. Now what is going to be the output of it? Is it going to give me in a positive number or as a negative number, or how is it going to be? Please remember, this is also going to be only 0. Right, but there is one small thing what you have to remember. If any one of the operand, if any one of the value is negative, so either it is minus 6 divided by 7 or 6 divided by minus 7. Now in this scenario, the output depends on my compiler. See, C language is a mission dependent language. So it is a mission dependent language. So result of this type of operation, that is whenever I'm going to perform a division on integers, if one of my operand is a negative value, so then how is my result going to be coming is mission dependent. So for this, it may give me the result either as 0 or as 1. So the result of this operation, that is when any one of my operand is a negative value. So the result of this operation can either be 0 or 1. And who decides that? It is a mission dependent operation. So we cannot predict the output of such a operation, such a expression. So it depends on the system, it depends on the compiler in which you are going to execute this particular program. So let us try this also out. So there you go. I'm going to say 6 divided by 7 for my first one. And then I'm just going to say minus 6 divided by minus 7. That is for my second expression. Okay, and for my third expression, I'm just saying minus 6 divided by 7. Now let me run this. Okay, see here. So first two, as I already told you, it is going to represent only 0. It is going to give me the result as 0. But the third one, it actually depends on the compiler and depends on the mission in which I am going to execute the program. So here in this compiler, it is giving me the result as 0. So remember, it can either be 0 or in some compilers, you may also get the result as 1. Okay, the result can also be given as 1. Right. Okay. And the next point. Okay, as I told you, the next point, what we should be doing when we are going to make use of our arithmetic operators is regarding the modulo operator. So regarding the modulo operator, so let us just say I am having a value like this. Minus 14 modulo 3. Okay, this is my first operation. My second operation is minus 14 modulo minus 3. And my third operation is 14 modulo minus 3. So when both the numbers are negative, when one, that is my numerator is a negative value and my denominator is a negative value. So how is my compiler going to treat this? So please remember, when I am having a result like this, whenever you are having an expression like this, what you have to remember is the result. The result of a modulo operation will always carry, okay, will always carry the sign of my numerator. Whatever is the sign of my numerator, that is what my result will be carrying. Okay, this is a rule that we have to be there when we are dealing with our modulo operator. The sign, that is the result. The result will have the sign of my numerator. No, what do I mean by this? So here, my numerator is what? My numerator is a negative value. Hence, the result also will be a negative value. The result is going to be minus 2. So here, again, my numerator is a negative value. I am not going to bother whether the denominator is a negative or a positive number. Again, here also the scenario is my numerator is a negative value. So my result also will be a negative. But here, what is the scenario? My denominator is a negative value. My numerator is positive. So the result is only 2. So remember, the result, the sign, what I'm going to get is always based on my numerator. So this is another very, very important thing you should know with regards to the arithmetic operator modulo. Right. Okay. So you want, let us execute this also. So let us just say minus 14 modulo 3 and then minus 14 modulo minus 3 and 14 modulo minus 3. There you go. See, check it out. So the first two is a negative value because my numerator is a negative number. The last one is a positive because my numerator is a positive number. So just remember this rule whenever we are dealing with our modulo operator. Right. Okay. The next important point with regards to the arithmetic operators, what you should be knowing is arithmetic operators can also be applied on the char data type. So you know that we have a data type called as char. Char data type is always internally treated as my integer only by my compiler because of its ASCII values. Okay, because every character is having an equivalent ASCII value. So the char data type is internally treated as an integer because of its ASCII representation. So the arithmetic operators can be applied on our char data type also. Say for example, okay, say for example, I am just taking this. So here, what I'm going to do is, I am going to say, okay, there you go. I am saying A plus A. So what is that I'm saying? A, this is a character. This is a char. Why? Because it's a single character enclosed within single quotation. So this is a char. This is also a char. So I can use like this also, or else create variables, no problem. Say C1 is equal to, give any value, whatever value you please, you can give here. So let us just say I am giving B, comma, I am saying C2 is equal to, I am giving the value as Z. Okay, so now what is that I'm going to do is, I am going to say C1 into C2. Okay, then I can take this out. Let me run this program. See what is the output you're getting. So how is it working? Based on the ASCII values. So just remember this. Now, for example, ASCII value of capital A is 65 plus ASCII value of small a is 97. So it is going to add these two values and then it is going to produce the output. Same way, ASCII value of B and ASCII value of Z. That is going to be multiplied and then that is going to be produced as your result. So this is what I said. We can make use of the arithmetic operators on the char data type also. And when we do this, how it is going to happen? It is going to take the values based on the ASCII numbers. Right. Now, I already told you that modulo operator, you cannot apply it on a floating point data type. So it is not possible for us. Then how to perform the modulo? See, when I do it, it's obviously giving me an error. Then how to perform a modulo operation on floats? I have a floating point variable and I want to do a modulo operation. So let us say I have a variable called N1. So I'm giving the value as 15.25. Okay, and I have another variable called N2. So let us say the value of N2 is going to be 5.30. Okay, just take any numbers, whatever numbers you please. And then I am going to say printf, I want to perform a modulo operation. I am saying %f. Now the problem is I cannot say N1 modulo N2 because that is not going to happen. So now how to solve this? For this only, I have a predefined function available for me. So please remember there is a predefined function called as fmod. Okay, so the name of the function is, we call it as fmod. Okay, and this function is used to perform modulo operation on floats, on floating point values. Okay, how to make use of this function? This function accepts two parameters. This function takes two parameters. That is what is going to be my numerator value and what is going to be my denominator value. I have to pass the two values inside this function as parameters. So now, where is this function available? This function is available under the header file. Okay, under the header file math.h. So if you want to make use of this function, so what you have to do, first thing is you have to include the math.h header file in your program. So that is our step number 1. So I'm going to include the math. So I'm saying math.h. Then I'm going to say f mod of n1 comma n2. So one is going to be my numerator and the other one is my denominator value. Now run this program. See, it is giving me the output. So now you know that whenever we are doing a float operation, by default it's supposed up to 6 decimal digits. After the dot, up to 6 decimal numbers it is going to get. So you don't want this much. So what I can say, I want only 2 decimal. After the dot, I want only 2 values. So you're just going to say 0.2f. Now let us run this. See, this is how I am going to be using my modulo on my floats. So how to do it is, I cannot directly apply the modulo operator. I have to make use of this special function called as fmod, which is available in the header file math.h. So this is how I will be going to be doing the operation of a modulo on floats. Right. Okay. And there is one more point regarding the arithmetic operators before we wind up this session. So that is how to do the power of calculation. See, generally, when we study some other programming languages, power of, we always represent using something like this. So I'm going to say 3 to the power of 2. Or else I can say 3 to the power of 2. So we use symbols like this. But here in our C language, we do not have any symbols or we do not have any operators for this power of. I cannot make use of any of these operators for the power of. Again, how to do the power of? I want to say 3 to the power 2. I want the result of that. So for that, again, I have a predefined function called POW. So what is the function? POW. So in this, what you have to give? The number. First parameter is the number on which you are going to apply. Then what is the power value? You want to raise it to the power of how much? That you are going to give it next. This is how we have to make use of this particular function. And again, this function is available for us inside the math.h header file. So if you are going to make use of, if you want to calculate any power of operations, then this is the function. And again, it is included in the math.h header file. Remember, there is no operator for power of. Okay, say for example, again, let us try it out also. So here I am just going to say, okay, percentage %d. Then I'm going to make use of the power function. So what did I say? POW within brackets, where you have to give the value. So I'm saying 3 to the power 2. What is going to be the value I will be getting? Sorry. So there you go. Yeah. So you're going to be getting the result as 9. So 3 raised to the power of 2. So that is going to be 9 for us. So any numbers, you can just try it out. Say for example, 5 to the power of 5. So this is the value you're going to be getting. So this is how I will be making use of the POW or my power of. Right. So these are the different arithmetic operations you can be performing on our variables. Right. Okay, guys. Thank you.